Dr. John Griffith, who's a principal scientist at the Department of Microbiology and coordinator of the molecular technology at the Southern California Coastal Water Research Project. He's been at the forefront of research to develop, evaluate, and implement methods of rapid assessment of beach water quality, microbial source identification, and detection of waterborne pathogens. When we were talking with him, he was up helping a community that was having some contamination problems. So I think he is the great next talk for, and as you know, this word has also been discussed a lot yesterday and today, sanitary surveys. So we moved from how EPA developed the recreational water standards. They got picked up by FDA in the produce safety rule, now to talking about sanitary surveys and ways we can identify hazards. Thank you.
Okay, thanks. It's great to be here, and it's been really interesting to me to interact with a lot of people I don't usually get to talk to. So other than Oren and Kevin, who are probably going to be bored to death with my talk, the rest of you are new victims for me. So I'm very, very excited about this. So anyway, I'm going to talk about sanitary surveys. And so first, some background. So sanitary surveys were first developed in the drinking water realm, right? And really to protect drinking water systems, and we can all relate to how important that is. And so these are typically conducted by a registered sanitarian or a trained professional, usually a third-party inspector, right? Because this is important enough, they don't want any bias. These are comprehensive evaluations, so they cover all aspects of from source water all the way through treatment, distribution, operator training. All these things are evaluated. And there's a standard format and checklist and so those ensure uniformity. And the idea is to try to make sure that nothing's missed. Okay, they've also been developed by EPA, and they've issued guidance for evaluating sources of pollution at beaches and both in marine and fresh waters. And the intent here is to actually improve water quality and to help managers kind of synthesize the condition of the beach and the data. And so the things that are looked at are water quality data, something that you all also are supposed to look at now. The pollutant source data, so identifying what the causes of pollution might be, and then also land use data. And then the idea is to use that data to assess potential health risks, and then you can also use repeated surveys to actually go back, and if you do pollution remediation, or what people call best management practices, or BMPs in the jargon, to assess whether or not those actions you've taken to clean things up have worked. So, how are they different than the annual inspection that you guys are now being asked to do? Well, sanitary surveys take a comprehensive approach to protecting and maintaining the source water and the distribution chain. And in fact, for drinking water, they even recommend that the municipal water districts or the water purveyors either buy the land where the water's coming from to protect it from pollution, or make agreements with landowners if they can't buy the land. And basically, they get a list of these are the things you shall not do on the land, right? That's not something that you have. So your inspection really kind of starts at your property line in terms of what's under your control. Okay. Sanitary surveys examine all activities in the watershed that may influence source or receiving water quality. They can be a long ways away, and they rely heavily on fine-scale data. So not the 5 times a year that are sampled, but often these samples can be taken daily in distribution systems to make sure that there's no bacteria growing and no pathogens present. But the produce safety rule asks only that you consider the water quality monitoring data, and they're requiring you to do that now. The nature of your source water, whether it's ground or surface, the extent of your control over the water source, the degree of protection of the water source, and then adjacent land use, so if you have grazing operations next to you, and also the likelihood that you might have a bad actor upstream. that's causing problems with your water. So, how likely is this guidance, in my opinion, to detect and identify microbial contamination? Well, the required monitoring is most definitely adequate probably to detect long-term trends, but you're not going to catch random events, right? So the hog waste pond that breaks open upstream, unless you happen to be sampling on one of those days when it's running through, you probably won't see the elevated bacteria from that, right? We're talking about changes in land use and construction. So you need to be aware of the activities that may negatively impact your source water. And this is an ongoing process. So yeah, it's an annual survey, but you need to be cognizant of this all the time, right? So changes in land use, I mean, somebody buys 10 head of steer and they're gonna run them on their property for 2 years and they weren't there before and they happen to be grazing in the stream. If they're grazing near the stream, they're probably also pooping in the stream, all right? You know, natural disruptions, fires and floods, right? So we have a river out there that's most definitely got sewage in it, right? Because the sewers are inundated. That's somebody's source water. It could also be septics in a more rural area where you don't have sewers. Okay, and then things like migrating wildlife. So we have Canada geese now that we never had in California. They're resident now. They, you know, we think sometimes I think that we need like English-style parks with big lawns and trees, even though we're in an arid climate. The geese love that, so they graze all day and poop all over the place, right? And so they're something that can definitely impact your water quality, especially when you're measuring things like E. coli. Okay, so those are kind of the basics of what a sanitary survey is, and if you want more information on the nitty-gritty and actually see the forms, they're all available on EPA's website, and you'll see they're quite detailed, right? And in fact, it will probably take a fair amount of work on your part to catch up with the jargon. And so I've actually tried to keep my talk as jargon-free as possible for you, all right? So if I break into jargon, I actually said BMP. I was trying not to. You know, you can throw spit wads at me or something. Okay, so what can you do when you've done your due diligence, and you've done your survey, maybe even done a more extensive, you know, pseudo-sanitary survey, and you still don't meet standards, okay? Well, you can treat the water, but that's a short-term solution. It's expensive. May reduce your productivity on your farm, may produce harmful byproducts that are another issue you're going to have to deal with. You could change your water source. For some people, that's an option, and that's great, but if you have to use, say, the municipal drinking water system, that can get pricey pretty fast. So the best solution is actually to find and remediate the source of the contamination. And so I'm actually going to pull a page from research we did when we had this same problem, but it was at beaches. Okay, and so you can replace the word beach with farm. And mostly we measured Enterococcus because we were working in marine water, but E. coli was also measured. And so the problem is, as Kevin pointed out, E. coli is a nonspecific indicator, so it's found in the guts of most animals. It can grow in the environment. The good news is there have been greater than 50 of these source-specific genetic markers or microbial source tracking markers that Kevin talked about developed, and they continue to be developed. But the issue for us was we needed to know they worked in our locale. And that's something, if you're going to use these markers, one of the first things you want to do is make sure they actually do work in your locale, and you don't have a cross-reaction with some other animal that happens to be common there, right? Because that can send you on a red herring. All right, so we needed to know if they worked for our beaches in California. And so we conducted a microbial method evaluation study as the first step. And we created a bunch of blind samples with various sources fecal material. And we had most of the methods run by multiple labs. And in fact, EPA participated. Orange Lab ran just a ton of these things by a bunch of different methods. And as you'll see, we had really broad participation. These studies come around about every 10 years. You'll probably see why as we go through them. They're not easy to do, but they tend to be pretty worthwhile. And the one before this one actually changed the whole paradigm with how we did microbial source tracking, kind of issued in the age of the genetic markers, or the beginning of using them. Okay, so here were our sources, and you can see we had 3 different kinds of human poop, because we have different ways of dealing with it. So we have individuals, say you had a homeless person that was pooping into your water. We've actually seen that. There was a guy at Topanga Creek that they called the Phantom Pooper, and he would every morning he lived in the brush, and he hung his butt over the rail and pooped into the lagoon. And my student workers were out there in the morning, and they actually witnessed the splashdown, so it was not pretty. Okay. We also have sewage, which is like what we have in the river right here, right? So municipal sewage that's escaped where it's supposed to be, now it's in the river and not treated. And then septage from septic tanks, right? And then common things like dogs, farm animals, a lot of the things that you might expect to see, and these are some of the things that we commonly see in our watersheds. And so we collected samples from all over the state, and we collaborated with folks at Stanford and UCSB and UCLA, and we divided up the work, and so we got sources from all these different places, including wastewater treatment plants and septic systems, and then of course the graduate students turned out to be the individuals that had to contribute. And because there are prohibitions against with human subjects rules at universities of actually having poop from people because it's considered tissue, we just had them transport it themselves internally down to our place, and then we gave them Tupperware when they arrived. So, not easy to do, but I mean, that's a really difficult thing if you're trying to do one of these studies. All right? And some of them did have some performance anxiety. Especially the folks from UCLA. I almost asked one of the Bruins that works with me to take one for the team, but he would not. So we had to wait for the students. Okay, so here are some of my staff. You can see how happy they are. They're surrounded by poop. No one wanted it into the lab, so that's our refrigerator there, and so they sorted it all out in the area. And these red ones, I believe those are some of the graduate students that donated. Okay, and then we mixed it all up, all right? And again, you see that these folks are outside under a canopy. No one wanted it in the place. But nonetheless, we persisted. And so when we started out, this was a 7-day operation. You can see here's my staff and a couple graduate students. They're all happy and everything. And then 7 days and 6,000 filters later, we had one of the professors and her kids doing it. The students were exhausted. So here's our participants, and the folks at the top, these are our collaborators that actually went on and did the rest of the work after this evaluation study, but this is essentially a who's who of microbial source tracking. Okay, and you may recognize some of the names. Okay? But the thing to see is, beside the universities, we also had universities and other agencies in Europe that participated, a good deal of federal agencies, and even some consulting firms, okay? And the deal is if we provided you samples, then you analyzed them for free and you gave us the data, and then we did the data analysis, okay? It turned out to be pretty expensive to do this. I was actually flying students down from Stanford as people were dropping and couldn't go anymore. Because the graduate students talk a good line, but after about 2 days, they start getting worthless, so we had to replace them. Okay, So I had three classes of methods. We had presence-absence methods. We had quantitative methods. Some of them detected a single source. Some of them were more community-type methods that could provide more than information on more than a single source. And we evaluated on these criteria. So could they identify the presence or absence of a host source in a sample? Could they identify the dominant source? Was there a lot more than the other source in there? And figure out what the relative contribution was. Some of them claimed to do that. None of them were really great at it, but they could get whether there was more of one than the other, how repeatable they were, and then could we combine them and provide more information than a single assay? And we tried to look at which combinations worked best. And so the outcome was we actually identified methods that were both specific and sensitive for 5 of the key sources we were interested in. And for our urban beaches, these were fine. For humans, dogs, pigs, cows, and gulls. But the biggest thing that maybe to come out of this study was we actually had consensus among the researchers. So as you saw, we had almost everybody in the field participate. And then we brought them together at our place to look at the data. And so these folks are pretty proud, and some of them have egos, right? And they're like, you know, they published on these methods. They said they worked. Lots of them didn't. Some of the things they thought were specific for cattle turned out to be much more of a general ruminant marker, right? But the cool thing is after they looked at the data, they could say, yeah, these are the ones that actually worked best. And so that is memorialized in a special issue of Water Research that was published in 2013 now, I think. But this kind of consensus is actually pretty rare in science. So we were very, very pleased with the outcome. But it's not enough to have methods, right? So you can develop lots of stuff in the lab, but how do you use it? And so what we did was we assembled 4 teams from our collaborators at the universities, and we did 4 beaches that were considered beach bummers. And a beach bummer is defined as a beach that gets an F on the Heal the Bay report card. So they actually collect data, and they have a rolling formula, and they grade these things, and people actually use these to decide whether they're going to a particular beach or not. So we had a Northern California beach, a Central California beach, an LA beach, and an Orange County beach. So we covered most of California. And the idea was to basically use these methods and develop protocols that we could give to other people to implement them. So we actually did find sources, and they're different than what we thought we might find. So at Cowell Beach, the suggestion was it's bacterial growth in the beach rack. This is a beach that has a lot of kelp. So these are, a lot of biomass, and it washes up on the beach, and the idea was the bacteria is growing on the underside of the kelp. And in fact, when we cultured it off the kelp, it was there, but it turned out to be a minor source. And what we found later using these source tracking markers is there was a buried storm drain that wasn't on the map, but it was on the beach, and it had a faulty sewer line that was leaking into it. And so there was actually sewage coming out on the beach. And the indicator bacteria actually telling us that it was there. But because it was hidden, it had to be the kelp, right? The local municipality was like, not us, right? But turned out it was. Okay? At Doheny, there are thousands of resident gulls. In the summer, it's probably, 1,500 to 2,000, and they go to the garbage dump and feed, and then they come back and hang out on the beach until they get enough people that they go out and kind of raft offshore. And the idea was the fecal indicator bacteria was coming from them. And in fact, that was part of the problem. The bird markers lit up, but we also found a really distinct human signature. And so we went back and did more testing because this was persistent. And especially it was most apparent when we had big tidal events. So, large highs and lows in the water table, which was making probably groundwater pump in and out. And so we put dyes in all their restrooms which the park department told us our sewers are tight, they don't leak. But it turns out with fluorometry, we were able to see the dye in the water within about 6 hours. And it ended up being all across the beach within 2 days. So we sampled every 2 hours for 48 hours. Okay? Then we had another beach. The suggestion was it's dogs. Turned out that was right. Source markers for dogs lit up. Didn't see very much human, very low levels, if any. But when we went upstream, what we found was there was a much higher signal. And it was, you know, a student actually walking up there doing surveys who almost got hit by dog poop coming over the fence that alerted us to the fact that the residents there were throwing their dog poop into the creek, right, to get rid of it. And so they actually did the local community did a big outreach, and they were able to actually lower the levels of bacteria at the beach. I don't know if it's still that way. There may be new residents there flinging dog poop again, but I mean, those are the kinds of things that you don't think about, but they're there, right? Okay. So what did we learn? Well, one of the first things we learned was you need to get everybody in the same room when you have a problem. So there are a whole lot of agencies with management responsibility. There are also property owners that have a stake in this, things like homeowners associations. For you guys, it's probably your neighboring farms. It's the folks upstream from you. Everybody has a different piece of the puzzle. And you might not be the only one that's having a problem with your source water. You start talking to each other, you may find there's some commonalities that point to a common source. And so that brings me to this, which is the simplest answer is often the right one. Right? So start by looking for obvious issues like leaking pipes or a cattle grazing operation where the cattle are standing in the water. If it's available, create a GIS inventory of the infrastructure. So in our urban environment in California, all the municipalities and the folks that own the stormwater sewers are required to have GIS layers available. And we were able to cobble those together for a lot of the beaches and identify where the sewer pipes were, how close they were to storm drains. And so that's been very helpful in a lot of places. Another resource for you might be if there's a TMDL in your watershed, there may be more monitoring data available to you that you don't know about. Because you're not the party that the TMDL is aimed at. It's the local government agency, right? And so if there's an enforcement action, that's public data, and usually those folks are willing to help. And then use a toolbox approach. So these genetic tools are really powerful, but the traditional tools are also a really important part of the solution. And, you know, starting out looking at your indicator bacteria levels and concentrations and doing more fine-scale sampling turns out to be a lot cheaper initially than going out and spending all your money on genetic tools. All right, there are folks that'll charge you $400 a sample to do these. All right, they're more price gouging, but they're still not cheap, right? So what you want to do is do your due diligence, do your sanitary survey, right? Get out there, do more frequent sampling if needed. Things like dye testing of septic systems can help. Sometimes what we find is, you know, especially on an old place where there's not much regulation, is the sewer has been straight piped to the creek. That's not that unusual, okay? And every flush is a bolus of bacteria that's going down into the watershed. All right, so we actually memorialized this in a source identification manual. This is available online. Like I said, you can replace, you know, beach with farm pretty easily. And then it actually had pretty extensive outside review. So the Clean Beach Task Force, which was the state agency that funded our study, reviewed it. It was reviewed by a consortium of water managers called the Beach Water Quality Work Group, which is organized by our State Water Resources Control Board and meets quarterly at our place in Costa Mesa. And then it was also reviewed by US EPA. Use a tiered approach, right? This is hypothesis driven, right? So you need to have questions. You can't go out there and say, you know, ready, shoot, aim. It's got to be targeted, all right? Identify the sources in your watershed. Go and check them off. If you can't eliminate them, then you need to do further testing until you can eliminate them, or you say, this could be it, right? Start with the less costly methods, and then localize and refine the problem. Follow the concentration, and then use the more expensive methods. When you do that, they're much more powerful, and you have to run many less of them. Okay, so this is not good if it's just at university labs in our place, so we actually trained up a bunch of folks to do these methods. And so a variety of labs throughout the state were trained, and we had levels of expertise from public health labs that do these methods for things like, you know, flu verifications or pathogen verifications from hospital samples, to folks that really just had like a technology degree from a community college and had no familiarity. But these methods are cookbook enough. If you train people well, it turns out you can get them to do it. So that we gave them a day of classroom, and we taught them to measure very small amounts of liquid. This is one of the biggest issues beside contamination control, is pipetting accuracy, okay? They got a day of hands-on, so basic qPCR proficiency. Could they run a standard curve? We gave them a dilution of a concentrated sample. Could they get a straight line, or were they all over the place, right? Were their blanks blank? Or were they a dirty operator and you know, we had to smack them on the hands with a ruler while they worked? And the goal was that they felt confident running the method. And then after they went back, we provided support to them. We acted as a help desk. I even loaned some of them equipment. And then we developed a web tool where they submitted their data, which is really just selfish for us, because I don't know if you've ever gotten the same kind of data in a spreadsheet from somebody and they all made their own spreadsheet and then you have to figure out how to put it into one. It's a nightmare. So that kind of collated the data for us and did some quality assurance checks. So here's who we trained, and you can see we have a variety of labs. So sanitation districts, city health labs, public health labs in Northern California, even the Monterey Bay Aquarium Research Institute. Kelly Goodwin came from NOAA down in San Diego, and also a consultant that wanted to learn this. And then we did an intercalibration because we needed to know, did the training stick? It's one thing to train them and watch them when you're right there on them. It's another thing, so several months later, can they still do it? So only labs that demonstrated proficiency were allowed to process samples in our next study, which was the whole idea of training them up to do this from our part. And so we had 8 labs. They all got a pre-intercalibration training package, so they got to practice for 6 weeks. And then they ran qPCR for human marker on blinded samples. They actually also ran the Enterococcus method. And they had duplicate spike test samples. And then we evaluated them on, could they produce high-quality standard curves from the reference material we gave them? Could they measure the target accurately and the concentrations? And then could they keep from cross-contaminating the sample during data and then do data analysis? So they did reasonably well. Most were capable of analyzing these. In fact, some of the folks with the least training did the best because they were so worried they were the most careful. And we actually had some of the folks that were pretty adept at this that were pretty cavalier and thought they could just do a great job, and we had to provide them some support because they underperformed, okay? And we still kind of serve as a reference lab for folks in the state. So this is just an example of their data. This is 3 different concentrations of the same standard, and the thing to see is all the labs are getting about the same answer. This is about a half a log around the answer, and so you can see the variability is pretty good. So we were pretty happy, and so we have the labs trained. A lot of these labs are using these methods right now. and we're not holding their hands anymore, okay? But some parting thoughts. These methods are mature, and when they're used with when sanitary surveys can't identify the source of contamination, they're pretty powerful. There is a manual, and it outlines a tiered, hypothesis-driven approach to conduct these investigations. You guys are going to run into instances where you need to identify and remediate fecal contamination in your water. And from my mind, and I'm just throwing Don and Betsy under the bus, Produce Safety Alliance is pretty well positioned to facilitate training of local laboratories. They know who's there, they know the people, they need the resources, and Don actually made me put in others because he didn't want to be by himself under the bus. So there you have it. Take any questions you have.
Thank you for that presentation. That was easy to understand and really great information. This question comes in from Washington. It's kind of a question/comment, perhaps not directly for you, but for FDA too. FDA recognizes that water used in different ways, irrigation, post-harvest, et cetera, and has different water quality standards. But swimming water is extremely different than ag water in terms of level and directness of exposure. So why are we using recreational water standards for ag water when the amount and timing and route of transmission are so different? And ending question, what has been done to translate these rec water standards to ag water standards?
That sounds like much more a question for FDA.
Yeah.
I can take a shot at it. So first blush, I'd say it's because there's been a whole lot of epidemiology and risk assessment in recreational water. And you'd have a hard time getting that kind of exposure to agricultural water. How many people do you think are going to line up to get dosed with agricultural water to see if they get sick? Right? Swimmers swim voluntarily. And so you have voluntary exposures. You can actually use that as a vehicle to do studies.
Does FDA want to respond to that at all?
So thanks for that question. As we talked about yesterday, the exposure rates are different for produce consumption as compared to primary recreation and recreational water. However, we did take that into account when proposing the requirements because we did incorporate other mitigation strategies as part of the framework. So it wasn't just that 126 and 410. It was the whole package of corrective measures associated with that as well as just those numerical requirements. Does that answer?
Yeah, I think they were just the connection. I don't know.
Yeah, you go to mine.
Did you want to add?
Yeah, so your wider audience can hear you.
Oh. I think that helps, provide some more background onto the reason for comparing those two. I think they're just noting that, there's so many different uses for ag water, and it seems that there's more to be expanded on there, and I think that's already a repeat of a theme, so double asterisk there.
Because of time, we're going to have to move on. I would like to thank Kevin again, and not Kevin, John.
Thank you, Kevin.
Yeah.
Thank you, Kevin.
Sorry, John.